In this lesson, we are going to study surjective functions. We say that a function is surjective or onto if every element of B occurs as the image of f of some element of A. So this is saying that if this is my A, if this is my A and this is my B, all the elements of B should be images of at least some element in A. So it's possible to have this one, that one, this one, this one, and this one. So in other words, there are no extra elements in B. So we cannot have something like this, like that. We cannot have that because we want the function to be surjective. So if that is the case, there are no extra elements in B. And of course, if f is a function, there are also no extra elements in A. For the definition of a function, you just know that there are no extra elements in A because all the elements of A must get mapped to an element of B. However, if it happens that there are no extra elements in B, we say that our function is injective. So for example, we have these two sets and this is our function. When we draw f, we have 1, 2, 3, and then we have 1, 2, 3 also. 1 goes to 1 goes to 2, 2 goes to 2, 3 goes to 3. I have 4 in A. And this one goes to 1. So in this case, we say now that f is onto or surjective. So this means that there is always at least one row pointing at any element of B. So again, if you will look at this one, there you go. There is always a row pointing to an element in B. So how do we now show that a function is surjective? What is the definition of a surjective function in symbols? Let me just go back to the definition. It means that every element of A, so we have for every element of B. So for every element in B, it occurs as the image of some element of A. What does that mean? So we have f of A is equal to B for some element of A. So we have here, there exists an A in capital A. Alright? Let me just write that down again here. For all B in the codomain, there exists an element in the domain such that this element is the image of this element in A. So again, this means that if you get an element in B, we can always find an element in A such that A gets mapped to B. So since we are starting with for all B, we get an arbitrary element in the domain. So in this case, we have let B be in B. And then here, we have a scratch work because this is an existence. So we need to find an A. So take note, this is scratch work. This is not part of the proof. We have to find that element A first. And then for step 3, you have to show that the A that you found really satisfies this property, that it is the image of this element that you started out with. So for example, let us show that this function is surjective. We already had this function when we were studying injective functions, right? This is a linear function that is one-to-one, and this is also surjective. So how do we give a final proof of that? First, we start by getting an arbitrary element in the codomain, and our codomain is the set of real numbers. So, however, just to indicate that we are working in the codomain, I will just use y. Let y be an element of R. Or actually, you can also use B if you want. So we can just stick with B, just so that you know that you are in the codomain. Let B be a real number. And then, for the scratch work, this is already step 2, we have to find, so this is not included in the proof, find A such that f of A is equal to B. Okay, so take note here that this is just my scratch. We want f of A to be equal to B, but f of A is 2A plus 1 equals B. And solving for A, we get that A is equal to B minus 1 all over 2. So therefore, you don't have to show this in your proof. You just now say that, you can now say take A to be equal to B minus 1 all over 2, and then show that this is really true, that f of A is equal to B. Note that f of A, which is equal to 2 times B minus 1 all over 2, is equal to B minus 1. Oops, I have a plus 1 in here. B minus 1 plus 1 is equal to B. So that's it. We were able to show that A is really the pre-image of B. Next, suppose that we have this one. This is again the function that we also discussed in the previous video lecture, f of x equals x squared. Is this function surjective? Are all the elements in the set of reals the image of some element in the set of reals? No, right? Because only the non-negative integers are images, right? Again, our graph is like this. So notice that the images will just be the non-negative integers. So of course the answer here is no, but how do you really prove that it is not surjective? So let us go back to the definition of f being surjective. This is the definition of f being surjective or one-to-one. So what is now the definition of f is not surjective? In symbols, for all becomes there exists an element in the codomain, and then there exists such that for all A in the domain, f of A cannot be equal to B. So how do we now get a counterexample? That is a counterexample, right? So proof. What is it? We know that negative integers do not appear as images. So for example, we can just take 1. So note that negative 1 is not equal to a squared, and that is our f of a for all a element in the set of reals. Why is it true that a squared is not equal to negative 1? Because the square of a real number is always greater than or equal to 0. So that's it. Next. What about if we now restrict the codomain? Actually, we're not restricting the function. We just changed the function. This is a different function from example 3 because the codomain is different. Okay, is the function f surjective? Yes. Correct. And for the proof, again, you start with getting an arbitrary element in the codomain. So this time around, let b be an element of 0 to infinity. It is a non-negative real number. And then we want to show that it has a pre-image. So again, for our scratch, we want to find an a such that f of a is equal to b. My f of a is a squared. So we have a squared equals b. What is the value of a? Take note that b is non-negative. So therefore, we can get the square root of b. We can do that. Actually, you can take a to be plus or minus square root of b. But all we have to do is to show at least 1. So this one will already do. So you can also drop the use of a. So I will just go directly to square root of b. I will just show that f of square root of b is equal to square root of b squared, which is equal to b. So this is it. This is already saying that the pre-image of b is this one, square root of b. I no longer used a. Here's another example. So we have a rational function from the set of reals. Take away 2 to the set of real numbers. Take away 1. Let us show that f is surjective. So again, we get an arbitrary element in the codomain. By the way, I just want to... Anyway. So we get an arbitrary element in the codomain. So let's call that b again. B, be an element of R, which is a real number but not equal to 1. Let's have our scratch work here. So we want to find a such that it's equal to b. We're looking for the pre-image. Our f of a is a minus 1 over a minus 2. This is equal to b. So this is just simple algebra. And we are solving for a. So therefore, our a is 1 minus 2b all over 1 minus b. So therefore here, in my proof, so I will just use this one. I will show that f of 1 minus 2b all over 1 minus b is equal to b. So I will just say note that. Again, I am not using the variable a. It's better if you avoid using another variable if that is possible. So f of 1 minus 2b over 1 minus b. This is equal to 1 minus 2b over 1 minus b minus 1 all over 1 minus 2b over 1 minus b minus 2. And then show eventually that this is really equal to b. I will leave it up to you to continue that. That is just algebra. Next, suppose that we have the set S. This is actually the power set. S is the set containing 1, 2, 3, 4, 5. And A is the power set of S. Take away the set containing the null set. Let us define this function from A to S by, take note that our domain is A, and A contains subsets of S, correct? So f of x, x here is a set, so that's why I'm using capital letter here. This is equal to the least element of x. Take note that the codomain is S, and that is a number, 1, 2, 3, 4, 5. Let us prove that f is surjective. First, you have to verify first that exercise. Verify that this function f, that this f is really a function muna. Show that f is really a function in the first place. And then, let us show now that this is surjective. So, what do? We get an arbitrary element in the codomain. So, therefore, an element here is either 1, 2, 3, 4, 5. But we want this to be general, so let B be an element of S. Our goal here say this is my scratch. Find a set X. Let's not call it X. Let's call it, okay, let's just stick with X. Such that f of X is equal to B. But take note, what is f of X? The least element of X. So, just to try out. For example, when B is equal to 1, what would be an element X that we can take? We want 1 to be the least element. So, we can have 1, 2, correct? But we can also have, just for it to be simple, this one. Correct? The least element of the set containing 1 is just 1. For example, 2, this is the image of the set containing 2. So therefore, from here, we can now generalize this. What would be the X? What would be the pre-image of B? That would be the set containing B. So we have, note that f of B, this is equal to the least element of B. And since that is the only element there, the least element is exactly B. So there you go. That's it. So that is why f is surjective. What about if we have a piecewise function? This is also, again, a function that we have already encountered when we were studying injective functions or one-to-one functions. And since this is a piecewise function, definitely we would end up with proof by cases. But first, we will start by getting an arbitrary element in the codomain. So that is an integer. We want to show that, for our scratch again, we want to find the pre-image. So we want to find A such that f of A is equal to n. What will happen here? Your n is either positive or negative, right? Just so that we get an idea of the pre-image, let us graph f. Oh, this would be integers. Okay, so if these are integers, So here we get this one, right? And then if n is less than 0, if n is equal to 0, we have this. If n is negative 1, so that's negative 1 plus 1. So that's also this one. And then if it's negative 1, that is, if this is negative 2, this one. So something like that. Okay. So therefore, we will divide our proof into two cases depending on the sign of b. I mean of n. So case 1, if n is greater than or equal to 0, what would be the pre-image of n? That is also n, correct? Because f of n is equal to n. Case 2, when n is negative, so just like here. So we have our f of n is now equal to n plus 1. Now remember that what you want is f of a is equal to n. But your f of a in this case would now become what? This would be f of n minus 1. This is equal to n minus 1 plus 1. So the image, the pre-image, I mean, of n is f of n minus 1. Okay, so is that right? When you have less than 0, so just like in this case, look at that. When x is negative 2, I mean when we have negative 2, f of negative 2 is equal to negative 1. And this is your n minus 1. What about negative 1? That is equal to 0. That's it. So anyway, so for our formal proof, we have case 1, n is greater than or equal to 0. Again, I will just write f of n is equal to n. Case 2, when n is negative, we have f of n minus 1 is equal to n minus 1 plus 1. Take note, we are using this because if n is negative, then n minus 1 is negative also. So this is equal to n. So therefore, we have shown that in both cases, we can always find a pre-image. Now take note that a function f is surjective if and only if its range is equal to its codomain. This actually follows immediately from the definition of f being surjective, because recall that strictly speaking, the range of f is a subset of the codomain of f. But from the reason that f is surjective, every element in the codomain f can be written as the image of some element in f, and that only means that the codomain of f is a subset of the range of f. Lastly, we will connect the two types of functions that we studied. If a function is both injective and surjective, then we say that it is bijective. So for example, this one, we have seen in our previous video lecture that this one is injective and this is also now surjective. So therefore, f here is bijective.